In this video, we're going to look at the concentration of different solutions. So concentration is a measurement of the amount of solute dissolved per unit solvent. So if you look in this beaker, you can see that the particles, the blue particles are the solute particles, and the purple particles are the solvent. So you have more blue particles per purple particles. So that would be considered a concentrated solution. Whereas over here, you can see that there are less blue solute particles per unit solvent. So that would be considered a dilute solution. And just by looking at them, their appearance is different. So here, this is a lot darker, so it is more concentrated, and this one is a lot lighter, and it's dilute. So we can visually distinguish that, but it is a measure of solute per solvent particle. Now, the concentration of a solution also affects how that solution behaves, and the properties that it has as a result of the solution concentration are called colligative properties. So they're properties that depend on the number of solute particles that are present. And the three colligative properties that I'm going to talk about are the lowering of vapor pressure, the elevation of boiling point, and the freezing point depression. So remember that vapor pressure is the pressure of a gas above a liquid. So if I had a closed container and I were to put it on a hot plate, that would start to heat, and we would turn some of that liquid into a gas. And as we did that, the vapor pressure in the container would increase because we would have more gas and more gas pressure above the liquid. However, for a solution, the vapor pressure lowers the more concentrated it is. So the particles of a solute are subtracted or are surrounded by and attracted to the particles of the solvent. So imagine, if we're talking about like salt water, imagine that the water is attracted to the salt that's dissolved in it. So the water tends to want to stay attached to those particles and not to escape and become a gas. So there's less kinetic energy and less tendency for the water or the solvent to escape, and therefore there's going to be a lower vapor pressure above that liquid. Not as much is going to be turning into a gas. Now, the boiling point is also elevated in a solution. So the more solute particles there are, the higher the boiling point is going to be. So again, just thinking of that idea of solvent being attracted to the solute, it holds on to the solute, so it creates a need for more energy for it to escape and become a gas. If we were to boil a solution, as water boils off, the solution becomes more concentrated because we're removing solvent and the solute is staying behind. So as you boil a solution, the temperature actually increases. So this is different than we learned in the last unit, where if we had just a pure substance like pure water, if we were to boil it, the temperature doesn't change. But in the case of a solution, if we boil it, it becomes more concentrated, and therefore the temperature will become elevated. Now, freezing point depression is probably the colligative property that you are most familiar with. So this is the lowering of the freezing point. So in the winter, we spray and spread salt on the roads, and basically what this does is it lowers the freezing point of water because we make it a salt solution. So it will have to be colder in order for the roads to freeze, and therefore it's more safe for us to drive around when it's around like 32 degrees. So again, one of the things that you can sort of envision when you think about freezing point depression is that the salt or the crystal structures, whatever's dissolved in the solvent, sort of get in the way of the solvent forming into a solid. So these are the three colligative properties that are affected by the solution concentration. Now, each one of them is dependent on the number of solute particles. So ionic solutes, remember that they're made out of ions that then are going to dissociate into that liquid. So ionic compounds tend to have stronger effects or larger colligative properties. We can observe them more readily because there's more solute particles. Rather than molecular compounds, they just dissolve as one particle. So if we look at sodium chloride, we would know that sodium chloride would separate into 2 ions, where calcium chloride would separate into 3. So we would see greater colligative properties in calcium chloride than sodium chloride because of the number of particles. Whereas glucose would be the least because glucose is just one molecule and it doesn't separate into its parts when it dissolves.